Okay, so today we're going to talk about classes, which includes methods and properties. We're talking about objects, that's usually what we're talking about, classes, methods, and properties, and then a whole bunch of other topics that come along for the ride. So by the end of this, we'll talk a lot about methods, what a method looks like, the different parts of it. If I say, what are the parameters of this method, you should be able to tell me, oh, I'll look at the right part of the method definition and tell you what the parameters are. Blocks and scope, we introduced the topic of scope and protection class and things like that last time, but I didn't really get into it. I was just throwing the terminology out there for you. There's a lot of things in object-oriented around overloading and overriding and things like that. So when we get into object-oriented topics, we have to cover what that means so that you'll know it when you see it and be able to apply it. Ambiguity is a problem in general when you start being able to overload things. Overloading simply means, what's a good example in English of a word that can have multiple meanings, and we're said to be overloading that term when we use it in different contexts other than maybe the pure definition of it. That's what we're talking about here. So when there's a possibility of having multiple methods that have slightly different definitions, but it's the same method name, then it can be ambiguous. Well, which one am I actually going to be calling when I try to write a function call for that method? So we'll talk about ambiguity a little bit and how to avoid it, how the compiler understands and interprets which method that you wanted to talk about. And then our assignment is going to be applying some conversion of decimal to other numbering systems and things. So I want to go over that a little bit and make sure that you have a fundamental understanding of it and understand where I'm coming from without assignments so that you can, I don't want you tripping over stuff that is silly for you to trip over. I want you to trip over the stuff in Java that I want you to figure out and understand. And then another important aspect of being a Java developer is to be able to put structured comments in your code, because that enables this tool that we call JavaDoc to be able to extract those structured comments and be able to write separate documentation about your code, basically for other developers. And it's very important if you're going to be writing like open source, or if your company is providing a commercial API that other folks can download and consume, then you'll want to know about that. If you go look at the Oracle webpage for Java documentation, well, that's where it comes from. They don't have a team of typists sitting over there and responding to every single change that a programmer makes and updating their documentation manually. They just recompile their code and it pulls all the documentation out from the changes that they made. So it's pretty powerful. So I want you guys to start being able to use that in your code, and when you turn things in, that way you'll be ready for it. When you show some of your portfolio code to a potential employer someday, then they'll say, oh wow, look, the person's already using JavaDocs. That's great. They'll fit right in here. So just as a review again, I keep pointing this out, putting this up here, but just want to keep reinforcing it. Our homework lifecycle in here, create a GitHub repository. It's empty, but then you have a repository, an empty bucket, in other words. You clone that locally on your local hard drive. You use IntelliJ or whatever tools that you're using, and you open that folder to create a Java project in the empty bucket. You write your code, you run it, you test it, you do whatever you're going to do for this iteration of writing the code. And then every now and then you commit your code, which is just, again, putting a stake in the ground and saying, okay, this version I want to be able to go back to at any point in the future. You can do it as often or as seldom as you're comfortable with, and with experience you'll begin to know. I will caution you that with experience you will also become lazy, and you will kick yourself for not committing as often as you should at some point. And you'll think, dang, I wish I had committed before I started ripping this code open and making all these changes, because it got way out of hand and I went down a rabbit trail here, and I'd really like to get rid of all this and go back to where I was when it was last working and start again. but you forgot to commit. Okay. Major checkpoints, you take what your local work is and you push it to the remote repository, and that saves it into GitHub for you. And definitely before you leave class, so you don't lose it on your computer, you want to push that to your remote repository. Then shut down the computer at the end of class to clear all that stuff off for the next person, knowing that, hey, all my stuff is out there in GitHub, so when I get home, I can just pull that down and continue where I left off. And this last note on here, I thought I had deleted this in the latest version of these PowerPoints, but I think we've got all the glitches figured out. But if you run into something, it's like, why do I have to keep doing this every day when I come to class? Why do I have to keep installing something? Why do I have to? Let me know, because I'm not aware of any glitches remaining like that. So I think that you all are out there happily sitting down at the computer and getting productive as soon as you show up to class, unless you tell me something. For me up here, I'm not writing Java at this instructor station, so as long as PowerPoint opens at the beginning of class, I think that everything's happy. So let me know if you're experiencing some pain out there, and we'll see if that's something in the category of things that we can fix. Okay, little question answer to start with. Looking at all the data types and things that we looked at, how did you feel about that? Was it confusing? Did it make sense? And you wonder why I'm still harping on it? The number of bytes. Were you able to create variables with unsigned values in them? And the last question was a trick question because Java doesn't support unsigned variables. So help me help you. What was straightforward and what was confusing about the data types?
When it came to using float types and double types, it's not that it was confusing, but I just kept on forgetting to include like the D or the F at the end of that variable.
Yeah, good point. I think I had a couple of examples of that. Let's see if I can make this bigger. So if we're happily coding along and so what am I going to get in answer if I execute those lines of code?
A double, right?
The answer is I don't know. It's ambiguous. I have to understand this particular language and the rules of this language to understand what I'm exactly going to get. Am I going to get 0? Am I going to get 0.49 something? Am I going to get something else? If I change this to a 5, 52 divided by 25, am I going to get 2? Am I going to get 2.1 something? What am I going to get in answer? I know if I put this in front of value 2, or in front of value, now it's going to typecast value as a floating point value, and then it's going to divide by an integer. And I know pretty much in every language that would return a double. And so answer would give me the 2.1 something that I am expecting. But yeah, this is ambiguous. I don't know. Some languages, it's going to say an integer divided by an integer is always an integer. And it'll truncate the decimal portion of it. And then it'll say, oh, and you wanted me to put that someplace. Oh, well, look at that. You're wanting me to put it in this big old float bucket. So I'll put my 2.0, my integer 2, into that big old float bucket, and it'll become 2.0. Well, what about the 0.1 remainder on there? Well, we lost that when we did the division. But some languages say, well, divide, it's possible to produce a fraction when I divide, so I'm going to define the rules of divide are that it always returns a floating point value. And so you don't lose it, even if you should lose it. I think Python is like that. I think Python says, you probably meant that you wanted a float answer. Because Python doesn't have declaring variables. It doesn't have hard and fast data types. But you get to higher level languages like C# and C++ and Java, you have to worry about this kind of stuff. And this has caused many a developer late night not realizing, well, obviously I should be looking for 2.1 something in this value, in this answer variable, but you don't. And if it's a graphics program, I'll tell you a little story. When I was working on this game, there was a really smart developer that was in charge of doing the physics for the game. It was a 3D space game called Allegiance. You can look it up. But when the ships met each other, they were supposed to have physics and bounce off of each other, right? And we said, okay, they're supposed to be enclosed by a sphere that represents their shields. And when those spheres hit each other, then they bounce off of each other. And worked great. You'd go up towards another ship and it would bounce off, you'd slow down. It was really cool. But I would drive the guy nuts because I would get a whole bunch of ships and I would go out there and I would line them up in a line, and then I would go as fast as I could go at the one on the end, and I would hit it, and all of these ships would start bouncing off of each other. And then by and large, you'd eventually hit one where the ships would be sitting on top of each other. And it just looked funny. And so I'd take a screenshot of it and I'd go down the hall and I'd show him. So he didn't like that. But anyway, when you get to working on things where math is important and the remainders and the precision of these variables is important, it matters. And you don't want to go to E3 or some game conference or something like that and show off your game and have somebody point out that your math was wrong. So it's important to know what the definition is. So the important thing is not to memorize how Java works. The important thing is to look up the order of operator precedence and what the data type is defined to be for these operations. If you go look up the Java division operator definition on Oracle, you'll probably find out that it says, well, if the left side and the right side of the equal sign or the divide sign, operand 1 and operand 2 are this type, you'll get this type back. My guess is if you start out with doubles, you'll get a double. If you start out with floats, you'll get a float. But again, if value and value 2 were float, then the definition of this would calculate a float, but then it would say, but then look at this big, huge, old, spacious double variable that I'm going to move that float into. And it would just move up to a bigger apartment kind of thing. So yeah, it's fun stuff. It's a thing that you got to know, got to understand programming in Java. Anything else? Okay, playing with GitHub. Everybody figure that out? How many people use their school account, email address, and how many use their personal email address?
I use the school when I get the student pack because it gives you a bunch of stuff.
There you go. So you get bonus stuff if you use your school account because it's .edu, and once you verify that it's a valid email address, you get extra stuff from GitHub. Nice. But you know, you might want to also have a personal account so that after you leave school, I don't know what happens with your email accounts after you leave FSW, but different schools handle it different ways. I've heard of people that still have their school email address from 20, 30 years ago in some places, so I don't know how that works, but yeah. Doesn't matter to me which one you use as long as I can get access to it when I need to grade your stuff out there. Okay, with IntelliJ, I had a couple of people that reached out to me, and it's perfectly fine. It's a common thing that people run into. If you start a new project in IntelliJ, you have to indicate what kind of project it is. It's like, well, teacher told me we were supposed to use IntelliJ. I didn't know that. I figured it was a tool that does Java. Well, it also does Node.js, and it does other kind of projects. So you have to pick Java as the project type so that it knows, oh, well, then you're probably going to want me to hook up to a Java compiler and all this other stuff in the background. So be careful of that. Easy thing to fix. Not a big deal. Better to figure that out on a hello world problem than some big complicated thing that your semester grade is going to depend on. Yeah, and then Java C and Java, finding those in your path, doing all that kind of stuff. Hopefully that's becoming familiar now. And then all the get commands. Any other questions? Logistics, tools, error messages? Because that's another part of learning Java is when you start compiling your program, what error do you get if you leave a semicolon off at the end of the line? What error do you get if you misspell double? What error do you get if you don't declare your variable ahead of time? Understanding what those things are. I'll tell you what I tell all of the beginning programmers that I teach, which is don't compare notes with the person sitting next to you to find out what those error messages mean. And I'll tell you why. You need to have your own list. This error means this in your words. Because the kind of errors that you commit are going to be different than the kind of errors that everybody else in the class runs into. Different people, like, I have this little glitch now and then when I'm typing certain words where my fingers just transpose some of the letters. And every time I type that word, I transpose those letters. I don't know what it is about the muscles in my fingers, but I find that I commonly do that. If I was trying to teach you guys how to avoid doing that and none of you had that problem, you'd be like, why am I wasting my time learning this technique when it doesn't ever happen to me? And it's the same with these errors. When you have an error in Java and you figure out what it was, make yourself a note. And then that way you will have your own little list of things that you run into. This comes to testing too. When you're looking for logical errors, you'll make certain logical errors more at different frequency rates than the other students in the class and other people that you work with, and you just have to know yourself. Yeah. Okay. Enough said. All right. A little bit about the order that we teach this thing. We get into these chicken and egg type of problems with teaching programming. So we started out the class teaching, the main function, and you put your print statements in the main to print hello world and all this. And it feels very comfortable and familiar to when we were doing Python and just doing procedural things, or if you've taken other programming languages and you just learn procedural things. Sequence, selection, repetition, the normal three control structures that we learn when we start learning programming. Nothing about objects, nothing about classes, methods, property, all this stuff. Well, why didn't we learn that to start with so we didn't have to stop and learn about classes now? Well, if we'd start teaching about classes first, we'd have the same problem. Well, then we get to a certain point and it's like, well, I need to put if statements and loops inside my methods, but I haven't learned about that yet. So it's a thing that people often struggle with, which comes first. And you'll even see textbook publishers, they'll advertise their textbooks as this is an objects first approach to teaching Java. Or they won't say that because it won't be objects first, it'll be procedural first, and then, oh, by the way, when we get to chapter 4 or 5, we'll throw in objects in there. So, yeah, it's just a sequencing thing. You know, it'd be nice if we could just teach you everything on the first day of class, but, you know, we have to kind of pick our battles as we go here. And Java also, the way it evolved, it didn't always start out being an object-oriented, and other languages have had this too, and then the object-oriented stuff was shoehorned in later, and so, you know, that main function always looks kind of conspicuous to me. You just pick some random old class, and you throw a main function in it, and now that's where the entry point is. Well, what if I had put that main function in some other class? Well, that class now becomes where the entry point is. So it just seems kind of contrived a little bit. What if you have two classes and both of them have a main function in it? Well, that won't happen, because as we know, the compiler looks for a main function to assign the entry point to in a class name, which is the one that you're compiling. You know, the project name and the class name, where the main function, they all need to kind of line up. It does an initial check for that kind of thing. It gives you a compiler warning or error if you break those rules. So, but like I said, it just always has seemed kind of contrived to me, because I learned procedural first, and then I saw how they shoehorned the object stuff in there later. Yeah, so when we start gently with methods, we'll just have a class wrapper on the outside, and we'll start putting methods in it, and those methods will call one another, and we won't get into the inheritance and all the other object-oriented stuff, just to kind of introduce you to the pattern of classes while utilizing things that you're already familiar with, which is just normal functions and parameters and A calling B and returning something back to A and that sort of stuff. But just realize in Java you can't have methods without classes. You have to have a class to put methods in. And then we'll get into the properties and all the instances and stuff. We'll start out easy and approachable to start with. So, a method. A method's nothing more than another name for a function, but we usually use the terminology method in object-oriented languages. So I will sometimes slip and call it a function, but when I'm talking about it in terms of object-oriented, I mean a method. So every class has methods and properties. You instantiate a class, and any class that you're going to use, you have to create an instance of it. It's like if you opened up your refrigerator and you saw a little dotted outline in your refrigerator for a carton of milk, but there's no milk in the refrigerator, right? If you want to drink milk, you have to create an instance of the milk by going to the store and purchasing it, and then putting it in the spot where the little dotted line for the carton of milk goes. Oh, now I can open up the refrigerator and drink the milk because I have an instance of a carton of milk. It's the same thing. I can theoretically have an animal class, but until I create a new instance of an animal class, I can't actually call the method or look at the properties of it. Make sense? So it's called instantiating an object. It's creating a new instance of a class, which also begs the question, can I have multiple instances of it? Yes, you can have multiple instances of it. Well, if you're going to have more than one of them, where are you going to keep them? And so we have variables. So we declare a variable just like we would a float or a double or an integer. We declare a variable whose type is the name of the class. Now I have a variable of type that class, and I can create an instance of the class and store the reference to it in that variable. And all this terminology, I'm hoping that I'm using it consistently and correctly, because that's the way we're going to start talking. Like we talked before, when you become a programmer, your terminology changes slightly, and you have to understand the buzzwords and the context and what it all means. So create a variable I create an instance of a class and store the reference in the variable. Once I have that, I use the reference to the object to access the methods and the properties of the object. We call that invoking. When I call the function, and we're talking about a class, that means I'm invoking the method. The same thing, I'll abuse that terminology. Yeah, so then back to our main function, who invokes that? We've written the hello world, maybe you've done some other stuff, but we've never written anything that calls the main function, right? That's true. However, the way that the Java virtual machine was written, when you say Java space and your project, that java.exe program opens up that, what do we call it? Not intermediate language code, but what do we call it in Java? I compile my Java source to
Bytecode?
Bytecode, yeah. So I've got this, so java.exe opens up your bytecode and it looks for that main function, the entry point, and Java calls it for you. And that begins the invoking of your main method and starts the running of your program. If it's a game, then inside your main function, your main method, you will have your game loop or something that leads to starting your game loop. If it's a Windows application, you'll have something in there that begins the Windows message loop. But it all goes through the main method. Yeah, I guess, this is just true in general. Like I said, my example earlier in Notepad was a bad example because I used the variable names value and value2. Well, what were those numbers? Was it the number of bananas in my shopping basket? What was it? It's always better to signal the intent of your variable when naming things, when you're programming. It's hard for programmers. I don't know if you've experienced this, but when we're writing complex algorithms, our brain, we're utilizing certain parts of our brain, which is the puzzle solving part of your brain. And then you get to the point where you need to declare a variable, and you know analytically that this is the place where I declare the variable, and then you ask your brain to give it a name, and it's like everything freezes, right? And it's like, oh, because you're moving over and you're trying to access the creative side of your brain. It's like, this is what I'm going to use it for. Give me a name for it. And the only thing that comes back is value2, because your brain said, okay, I'm not waiting for that guy. Value2. Yeah, it's hard. But like I said, in general, methods no different than variables. We want to try to use a good variable name that signals the intent. We don't want to use just function 12 as the name of our method. Yeah. So the parts of a method. So we're going to have a signature, declaration, and it's going to specify a bunch of stuff. So it might be easier at some point for me to switch over to IntelliJ and illustrate some of this stuff. Did I say Java? Yeah, Java. So we've got this main function. Okay, there's something on here. I always have to be reminded, how do I make the font bigger in IntelliJ?
I usually hit the double shift, or hit shift twice, and then just zoom out that way. Double shift should bring out like global menu.
It didn't.
Oh.
Mm. It says control key, but that doesn't work. File, settings, editor, general. There's supposed to be something in here. Change font size and all editors. There we go. There's always an answer. So I got my little welcome message, main method, print. Okay, so I've got my thing and I wanted to create a method. Okay, well we can look at the main method to start with. That's a little bit more than what we wanted to. Public, integer, looks like, okay, so I've created inside my main class, I created a method called looks like. IntelliJ makes it look gray because there aren't currently any place in the program that calls that function. Notice main is blue because it is called by the JVM, but it's cheating. It just knows that. The different parts to this that we're looking at here, access specifiers. Okay, like I said, we mentioned this last time. Public. Public means, so I'm being lazy here, I'm just making it public. Public means it can be called by anyone, anywhere. If I had been being a little bit more precise, I would have started by making it private. This is a good best practice to make things the least accessible that you can until you know you need to broaden it. And then you examine the reason why you need to broaden it. And if you agree with the reason why you need to broaden the access, you go ahead and do it. With experience, you'll get to a point where, well, I know the context where I'm going to use this method, and I know that it's going to need to be public, so I'm going to define it as public to start with. And that just saves you the headache later of having to come back and rework it and do all this analysis. But as a professional software developer, you want the principle of least privilege to be used, and you should start by making it private to start with. So a private method, where can that be called? Only inside this class. Only inside the class where it is defined. So I can call it here. What are you complaining about? Oh, yes, okay. I could call it, except that from a static method, that's even more restrictive. From a static method, you can only call other static methods. And that negates something that I stated as an absolute earlier also, which is if I want to call any of the methods in a class, I have to create an instance of the class. Well, that's true except for static methods. Static methods inside a class, you can call them without having an instance of the class. Okay, so that's why main is a little weird. It's shoehorned in here, it's special, it's called by the JVM. It doesn't follow the typical general practices of object-oriented that we're talking about. So I cannot call looks like inside here because looks like is not static. If I said static, then yes, from a static method, I can call another private static method as long as it's in this same class. If I had another just to be consistent. Okay, so I have another class. I can't call that from in here. How would I even do it? Right? First thing it says is, what are you talking about? I can't resolve what you just typed. There is no such method as other method. This is violating scope. So other class has a method called other method, but this code in here can't even see that. It's not even in the same scope. Remember we talked about the scope last time? You're looking at a certain area and you can't see anything outside of that scope. If I typed other class dot other method, oh, it changed color. But I still have the squigglies. It says it has private access in the other class. So now it's in scope because I've qualified it. I said I want you to go to that class and find this method over there. And it says, okay, I can see it. It's now in scope. But sorry, that's defined as private. It's a private class with a private method. So being a private class, that's fine because we're in the same file. But the method inside there, you're not allowed to call the private methods of another class. Period. Even if it's static. It violates the access specification of that method. You see how this can kind of run down lots of different rabbit holes depending on what we decide to talk about? It's a lot of information to throw at you at one time. And I'm just trying in my head to make sure I hit all the things. But it's a lot easier to look at tangible examples of the code and have them to refer back to put it in some context. So that's why I'm doing this. So if I had made this public, yeah, so now it's claiming them as other method returns something and you're ignoring it. You're not using the response. You know, Java in general is very good about error messages. IntelliJ is a very good editor for indicating where there's a concern. You know, it's yellow, which means it's just a warning. It's, oh, be aware of that. You know, but you'll get a feel for this and it becomes an environment where you can be very productive and fix your problems as you go, working in IntelliJ, which is the reason why I like it. So I'm very happy that you guys get student licenses of it to use for free for a year. That's very nice. You can get all this experience with a professional editor. Okay, so back to this. Well, since I've already created this other class over here, let's get rid of the static. We'll leave it public for now. Give it some logic, return a value. Now I can talk about, this is a more traditional, what are you complaining about now? Oh yeah. So now it's just complaining that this is supposed to be in its own file. Fine. New file. Other class.java. What now? Oh, it's never used. Okay, I can deal with that. I'm about to fix that. Leave me alone. Okay, so now I have a more regular looking class. With a regular looking method in it. So I'm going to create an instance of object other class. Other class. And see this? The pop-up stuff? Again, as a professional, this makes you extremely productive. I told you, taking a typing class or a keyboarding class more specifically, because nobody uses typewriters anymore. If you take a keyboarding class, they go through specifically how to use a computer keyboard. It's very important that you learn to type without looking at your fingers. Well, same thing. These editors have these great type ahead features so that you type part of your code and you just hit the tab key and it types the rest of it. I encourage you, like I said before, to develop the muscle memory of typing this stuff yourself for a while so that you remember what the syntax looks like. So I created an instance of the object. This introduces the new operator. We've not had to use the new operator before. As I said, the Java virtual machine creates an instance of the main class if it needs one, and it makes a static call to the main method in that class when it needs to call our entry point. So we don't have to worry about any of that stuff. But if you want to have classes and you want to have objects and methods and properties to use, you have to use the new property. So I create a variable to store it in. I use the new operator. I specify the name of my class, and I get a new instance of it. Another thing to point out, if I have a variable up here, again, I know it's a lot, bear with me. This variable count is how many bytes of memory? 16?
4.
42? 4, right. An integer in Java is a 4-byte data type. Values from -2 billion to 2 billion. Just get comfortable with remembering those kind of facts so you know here's the range of values I can store in this variable. The 4 bytes for this are going to be stored on the program stack. When Java compiles your program, it allocates a stack, like a little scratch pad for your executable, where it's going to start hacking up that memory and putting all of the local variables. This is a local variable because its scope is to this function. So the local variables in your program are stored on the stack. So by declaring this variable here, I've told Java, set aside 4 bytes in that scratch pad called the stack, 4 bytes. And I will refer to those 4 bytes by the name count. However, it gets a little complicated when we're talking about the new operator. So other class is a variable. Well, how do I determine how many bytes I'm talking about here? Do I have to go down here to the other class and try to do some kind of arithmetic to try to figure out how big it is? Yes and no. You need to know that, but not for right now. This variable is not an other class variable. It's a reference to an other class object. So all I need to know here is how much memory does it take to store a reference to an object? And it depends. Depends on what the word size is. You can change the properties in the Java compiler and things. But I think it's 4 bytes. Similar to an integer, but it's just a reference to an object is 4 bytes of memory. So in this line of code here, I've declared a variable of type other class, which is a reference to an object, so it puts 4 bytes on the stack. So now this variable is consuming 8 bytes on the stack, 4 for the integer count and 4 for the reference to an other class object. Additionally, when this executes, now all that happens at compile time. When you compile the code, the Java compiler looks at your source code and it says, you've written code that references 2 variables, so I know ahead of time I need to reserve 8 bytes, 4 and 4. But the memory for this instance of an object, and it will be however many variables you have defined inside, properties that you've defined inside the other class object, that will determine how many bytes we're talking about here. But those bytes don't get put on the stack. They come from what we call the heap. And that's the big blob of general RAM that your computer has available. And you can virtually ask for many gigabytes of memory. Now you can't actually ask for that many, but you can virtually, they call it an address space. At some point we got virtual memory, and essentially the compiler is kind of winking a nod saying, okay, we'll pretend that you've got all of this memory available to you, but you really don't. But in essence, practically, it doesn't matter. Because if you were writing a program where you actually needed that much memory, you're going to run into other problems before you get to the, oh wait, you've used up all the memory on the machine. Right? Just the sheer amount of time that it's going to take for that program to execute. And it's usually going to represent some logic error if you ever get to that point. For the kind of programs we're writing in this class, it doesn't matter. You've essentially got unlimited memory that you can expect to ask for on the heap. So I could ask for 10 billion of these other class objects, new instances of them, and compiler's going to say, yeah, that's okay, it sounds reasonable, good job. So at runtime, so at compile time we get the local variables. At runtime, when this line of code executes in real time, it will go out there and ask from the heap for enough bytes to store one of these objects, and it will give you the reference to that memory location back and store the reference in other class. Get how all that flows? It's really confusing, I know. But that's how it works. So I could do it again. I could do it again. I could create as many instances of this as I want. Now what happens here? So other class is already storing the reference to an object, to a blob of memory, right? Then I get the next one, I get the next one, and then I come down here and I reuse this variable name. I allocate a new object, but I'm storing the reference in this variable that already contains a reference to a variable. Am I going to get a compile error? Am I going to get a runtime error? Notice IntelliJ says, yeah, that looks cool to me. I don't see any yellow squigglies. I don't see any red squigglies, nothing. So Any theories as to what's going to happen here? It looks kind of weird, right? Why would I throw away this perfectly good object up here and create another one?
Would that be considered a redeclaration of that variable?
Not a redeclaration, it's just a new assignment. I'm assigning an instance of this object over the top of the instance that I was already looking at. It's perfectly fine to do that, and it happens all the time for very valid reasons, logically. And what happens is there's some processes running in the background in the Java virtual machine that are watching for this. We have this thing called reference counting. So every object in the heap that's allocated has a reference counter. And every time you make a new assignment, because that's the other thing I could do is I can say, well, I'm going to create a new instance variable, and I'm going to point it to the same object that other class 2 is pointing at. Okay, so I've got one variable that's pointing at two objects. Well, it was pointing at one object, and now it's no longer pointing at that because it's pointing at the newer object. And then I've got two variables that are pointing to the same object. So I see some squigglies here. Let's see what it's going to say about that. Yeah, okay, local variable foo is redundant. Okay, so it detected the fact that I got two variables pointing at the same thing. And it says, yeah, that kind of looks weird. You might look at that code. Did you have a typo in the variable name? Did you mean to use other class 2 in that context? But okay, so that's fine. But same situation. We got one variable, two objects, two variables, one object. And yes, that's perfectly fine to do this logically in your program if that's what you meant to do. In the first case, when we do the second assignment, the reference counter on the first object now goes from 1 down to 0. There are no references, no live references in your program anymore to that blob of memory on the heap. And so at some point in the background, the garbage collector is going to come along and it's going to look through the heap, and any objects that have a 0 reference count, it's just going to reclaim all that memory. Okay? Is it going to happen instantly? It's going to happen 30 seconds from now, 30 milliseconds from now, 2 hours from now. We don't know. If you're writing a very memory intensive program and you need to take charge of the garbage collector and you need to say, okay, I'm done with this really memory intensive part of the program. I need you to explicitly go reclaim all of the unused memory that I just freed up because I'm getting ready to do something memory intensive again. Yeah, there's things that you can do with the garbage collector where you can take steps to direct its efforts, but 99% of the time you're going to make the problem worse if you try to step in and try to second guess the garbage collector because it's been around for a long time and it's been pretty well refined. Best practice is simply let the garbage collector do what it does and ignore that it's there. And I say ignore that it's there, but I put a little asterisk. You don't intentionally want to do things that are memory inefficient, that are wasteful of memory on the heap. The heap is slower than the stack, but the stack is very limited in size. It's a compile time setting what size stack that you're going to have. If you're going to write some commercial application that is going to have thousands of methods, and you're going to have a call tree that goes very, very deeply, then you may find a situation sometime in your career where this program needs to have its default setting bumped up, where you give it a larger stack, because you're going to have a lot of local variables, or you're going to really use the stack a lot. But most of the time, same thing as the heap, as the garbage collector. Most of the time, the default stack size is fine for the kind of local variables and parameters and stuff like that that goes on the stack that you're going to need. is probably fine. You can ignore it for all intents and purposes unless we are talking academically and we're learning how all this stuff works like this. Okay, so let's get rid of the weirdness. So again, we're back to, I have a reference variable. I created a new instance of the other class object. I'm storing that reference in the other class variable. And now I can call any of its public methods. I can access any of its public properties. Now you saw me create that class. What is this pop-up talking about? It's got a whole bunch of stuff in here. Where did all this, I mean, I didn't write any of that code. Well, what you find in Java is that even though I just created this public class, other class, all classes in Java, by definition, are derived from, I think it's actually system.object. They're just explicitly derived from system.object. So you inherit everything that comes, that somebody else wrote that's part of system.object class. You just get all that stuff for free. So that's what you're looking at here. When I say other class dot and it brings up the autocomplete list, yeah, my method is up here at the top, but all of that other stuff is built into system.object and we get it for free. Well, not free, but cheap. And you can't get rid of it, so you might as well just accept it. Another note about the editor here. It is putting this age colon in here. That's not something I typed. And it can be confusing if you're trying to learn this on your own. You might like write down in your notes that I typed age colon 55. No, I didn't. We know, looking at the class and the method definition, that it takes an integer that we called age as a variable. This is just the editor trying to be user-friendly and reminding you that that 55 is what we're passing as the age parameter, okay? You know, I'm sure there's some option where I can get rid of that, go back down to just bare bones, just show me what I typed. But this is the way it's set up by default. So just don't trip over that, don't be confused by it. The editor's just trying to be helpful. And you don't have to type the name of the parameter. You can, I think. There is a way to do that, I think, that named, but I don't think it's legal in this. So I'll have to remind myself what we're talking about there. So for now, just ignore it. Comes for free. So now this line of code is I have accessed the reference to the object that I created on the heap. I'm calling the public method of that object called other method, and I'm passing it the value 55. I could pass it count. I could pass it you know, I could pass it any expression that I want to, as long as, now I've got the red squigglies. Anybody guess what the red squigglies are going to be telling me? I've got a guess based on what we were talking about with the data types earlier. Let's see. It requires type integer, but what you provided is an expression that evaluates to a double. And it says, yeah, I'm guessing you didn't want to do that. I'm guessing you probably wanted to pass an integer. So I can make that go away by simply manually, what? There. So I typecasted the result of this expression, which is a float or double, and I typecast it as an int, and I said, yes, I want you to truncate that for me, please. And now it says, okay, yeah, I don't know what you're doing, but you apparently meant to do that, so sure, I'll get rid of the red squigglies. Make sense? Okay, so the return value. So now, since we know that other method is set up to accept, or it's defined to return a value of type integer, and we were before ignoring that. So now I've declared a variable on the, where is this int 4-byte variable going to be located?
Stack.
On the stack. So on the stack, I've allocated another 4 bytes and set it to whatever other method returns. Okay, so now I can print the value. So now it's starting to look like a little bit more of a meaningful program. You know, whether it does something useful or not, that's up to you to judge, but at least it does something. Critiquing myself, I probably could have picked a better name for other class, better variable name. So if you turned in this for this assignment, that's probably what I would do is I would look at this and I'd say, hey, why are you being inconsistent between using integer and int? Pick one. I don't care which, they're synonymous, they mean the same thing, but pick one and stick with it. Okay, fine. This is no big deal. I'd say, yeah, you want to use a more meaningful class name, more meaningful variable name, more meaningful method name. Maybe a comment here saying, get the might say put a print the results line here, but you know, it's looking pretty good. Okay, rabbit trail over. Let's get back to the main point, which is the parts of a method signature. So I've got a method here, access specifier, return data type, whatever expression it's going to return now has to be that data type. The name of the method, use a meaningful name. The parameter list, which includes for each parameter the data type of the parameter that you're going to pass, which then it has to be that data type. And the name, use a meaningful name. I'll make this a little bit more consistent. Oh no, one related problem. What's it going to be? Any guesses? What problem did I just create? Well, I added this parameter to this method, but something is calling the old version, right? So now when I come down here and look, I got red squigglies here too. It says, oh, I'm expecting 2 arguments. See, again, the editor is being nice. It's saying you're passing the age and the difference. What if I had gotten these backwards? Oh yeah, I forgot what order I defined them in. Well, the editor is letting you know, oh no, this is the age parameter. Remember, that's what you're passing in. Okay, I'll fix it. Now we're back to good again, which is kind of nice. You know, now the related problem goes away. Says there's one place where it's being used, all these really nice, helpful things. Other classes being used in 2 places, etc. Okay, so we got access specifier, return type, method name, parameter list. Each parameter has a data type and a name of the parameter. Then it has a method body. The method body is enclosed in curly braces. We've got a style thing here like we talked about before, coding style. You know, some people are religious about wanting the little semicolon to be on the same name as what is being defined. I grew up before those people and I've always done it this way, so I like it. My brain doesn't hurt when I look and I see all the curly braces lining up. Ah, yes, my brain feels better now. I can see things when things start and stop. But other people are like, look, you're wasting 2 whole lines of code. I'm like, yes, that's why I have this incredibly huge monitor where I can put the font size down to this, and I can see all my code on the screen, so I don't need to save those 2 lines of code like I did in 1980 when they came up with that rule. Okay, so that's all the points. So I spent a lot of time on this, and once you get in here, once you get in the body of the method, we go right back to CLP 1000 rules. It's just a function. It's just a linear, sequential set of instructions with if statements and loops and other stuff, just like before, okay? Any questions there? Okay. I don't see anybody going like this saying, why did I sign up for this class? So I'll assume everybody's okay and I can stop beating the dead horse. Okay, I think I already talked about this. Okay, there are 3 ways that a method can end. This method ends when I return an expression, and that expression has to match the data type of the method, okay? That's how this method returns. If I had another method, I could just say return. You know, it's defined to return void. Void means nothing, means I'm not going to return anything. Yeah, sure, you can pass me stuff in here if you want to define the method to accept parameters again still. But it doesn't return anything. In that case, I can just say return. That's when this method ends. Also, that is synonymous with not saying anything, because whenever it executes the closed curly brace at the end of the method definition, that's when the method will end on a void method. You know, why have the return statement at all? Because I might have something in here that says, you know, I might have something in here that has some conditions around when it returns, or you know, I might have some condition where I evaluate this expression. Of course, that's a silly one, but but I evaluate some expression, and if that expression is true, okay, well then I'm done. I don't have any more work to do, so I leave. So that's a reason why we have the return statement, is sometimes we want to not just fall through to the end of the method and have it return there. Make sense? Okay, also if the method throws an exception, so if I have int x equals 4 divided by 0. Okay, so whenever I execute this line of code, it's going to, this says numeric overflow, but typically you'll see something like divide by 0 error, and it'll throw an exception when it tries to execute this line of code. It says, what are you talking about? You can't divide by 0. But in some contexts, they let you do that kind of thing. They just say, okay, x is going to contain a special value called system.infinity or map.infinity or something, and they'll let you do it. But for all intents and purposes, I did something here that threw an exception. Well, if that happens, the exception handler takes over and it rips control out of your method and says, you're done. You've had your chance. Your fake ID has been detected. You're not 37 years old. So you're out of the club. Yeah, so then this bears mentioning what happens when we hit the end of a method through a return, through an exception, through a closed curly brace. All of the things that were on the stack, all the variable names that were reserved and compiler was ready for you to use, the variables go out of scope. The memory held by those variable allocations is returned to the stack, and objects sent to the garbage collector. So how does that happen? So if we look at our code here, let me get rid of that offending line of code. Okay, this is our method. So right here I declared the object. Here I instantiated the object. Here I accessed one of the methods of the object via its object reference. And then I came down here and I hit the closed curly brace for this main method. So as soon as I execute that, well, count goes out of scope, and those 4 bytes are returned onto the stack. Other class, the variable, goes out of scope, and those 4 bytes are returned to the stack. Return value goes out of scope. Those 4 bytes are returned to the stack. But remember, out here on the heap, I had allocated this object, and the reference to it was stored in this other class. So likewise, in my previous example, when I hit this closed curly brace, and other class variable goes out of scope and goes back on the stack, now we have no more references to this instance of the object. And so, like before, the garbage collector runs and says, oh, look at that, I see an object out here on the heap with no references, and it reclaims that memory and goes back to 0. So that's what happens when I hit the closed curly brace. Yeah, if I had code out here, let's say return, and then I had a line of code down here, I immediately get the red squiggly treatment, and it's going to say, hey, that's unreachable. And I think it's pretty clever sometimes how the compiler, or in this case the editor, which I think is still using the compiler, I think what it's doing is it's taking snippets of your code and it's in the background passing them to the compiler or some API that the compiler exposes. I don't think they rewrote the entire Java compiler to do this, but just guessing. But it's pretty clever sometimes how it can detect unreachable code. And clearly, it doesn't make any sense to leave instructions in your source code that can't ever be executed. That's just wasteful. It's not wasteful of memory, because there's no memory allocated for unused code. There's no, well, I guess technically we could be allocating 4 bytes on the stack that we're never going to use, if the compiler let us get away with this. I'm not using anything on the heap, because this line of code never executes to allocate anything from the heap. It doesn't waste time. I'm not wasting any CPU cycles, because again, the code is never executed. But it's wasteful of some other resource, which is the number of bytes of bytecode that the compiler generated. When it converted all my source code into bytecode, this is just bloating the size of that bytecode file. And so if I had many classes and methods and lots of code out there that the compiler was having to compile and then store in my bytecode file, it's just wasteful. It's just making the program bigger than it needs to be. And if you've ever wondered, why is it I'm downloading this stupid little tic-tac-toe game on my phone, but it's saying that I need to download a 37 meg module to my phone to play tic-tac-toe? Well, there you go. It probably doesn't need that. It needs all that extra room for the dead code and the advertisements and the ability to take your credit card without you knowing and all that kind of stuff. So anyway. So yeah, dead code. Don't write dead code. Yeah, there's our example. The live example I think was more useful. All right. Cleansing breath, sip of tea. Number systems. So in your math classes, maybe in elementary school, maybe junior high, maybe never at all, I don't know where they're putting this nowadays. But at some point in my education, I had to learn numbering systems, bases, in other words. So we were, born with 10 fingers, and so we typically count base 10. And that worked great for many, many years until we invented computers, and computers were only smart enough to have zeros and ones. So we string a whole bunch of those together, and we can get bigger numbers, but it's all based on the 0 and 1. So you can think of your computer only having one finger, which is either up or down. All right, so where do we get the other bases? Well, 2 is the 1-digit on and off, 0 or 1 numbering system. So I can count as high as I want to go with base 2 numbering in binary. That's what we call it. Each digit can only be 0 or 1. And there's a few things that are common as we define each of these numbering systems. There's the base. The base is how many individual digits you can put in one position, one column, okay? Binary, base 2, I can have up to 2 unique digits. Now, whether I make those red and green, or a couple of Greek symbols, or okay, let's keep it easy and make them 0 and 1, doesn't really matter. As long as I have 2 symbols and only 2 symbols possible. All right, go to base 8, octal, which we don't talk a lot about, but we can count in base 8 arithmetic. So that means we can hold 7 or 8 unique digits in one column, and we typically, by convention, use 0, 1, 2, 3, 4, 5, 6, 7. There's 8 of them, so it's base 8, 0 through 7. Okay? So we can go 0, 1, 2, 3, 4, 5, 6, 7, 10. So we carry the 1 and start back over at the first symbol in the first position. 1, 2, 3, 4, 5, 6, 7, 20, right? The terminology gets kind of weird because all of our names for numbers come from base 10 because of our 10 fingers and toes. So we're abusing it or overloading these terms when we start talking about different number systems. When I use the word 10 in base 8, I mean the digits 1 and 0, which is really 8. It's the decimal number 8, okay? So that's where this stuff gets confusing. We don't usually talk about 8 because 8 requires 3 digits. And we don't have bytes on our computer where we can store 3-digit values. So yeah, we just usually skip right over 8 and go to 16. Because 16 is 4 binary digits, and if we can basically take, let's see, it's base 16, so I can have 16 unique digits. So we got 0 through 9, and oh, we ran out of digits, so we have to borrow from somewhere else. Okay, so nobody knows Greek numbering, so we're not going to use Greek symbols, so let's just use A, B, C, D, E, F. So that's how we get hexadecimal numbering. So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 10. We go back to 1 and then carry the 1, and we go back to 0 in the first position. Okay, so that's hopefully a reiteration of the base numbering schemes that I learned at some point in my education. Okay, we talk about bytes. 1 byte is 8 individual zeros and ones, and we do that. Why don't we have a half byte? Why don't we have a 4-digit, 4 bits, 4 zeros and ones? We could. There's no reason why we can't. But somebody at some point decided that we're going to build all the processors to have 8-bit bytes instead of 4-bit bytes. I don't know. Maybe there was an intense discussion, papers written about it, and they debated and competed with different computer models and stuff back in the day. I don't know. I've never heard of any of that. By the time I got my first computer, bytes were 8 bits. Okay. So you can see some of this stuff is all abstract and fairly arbitrary. We're just basically working on conventions. Okay, some other stuff, signed, unsigned. Java doesn't have unsigned arithmetic data types, so we don't have to worry about signed and unsigned. But that means that every single data type, every single numeric data type in Java reserves the highest bit for 0 for positive and 1 for negative. Again, just convention. Some of it's convention, but some of it goes to this 2's complement arithmetic. You know how when they defined algebra, somebody designed the square root symbol, and that's what we're going to use to represent the square root. Somebody said the little superscript 2 is going to be for when you square a number. Just convention. Well, when they defined the algebra for converting base numbering systems between one another, on a computer, they defined 2's complement arithmetic. And if you Google 2's complement arithmetic, you'll get a really good explanation of how it works and the idiosyncrasies of it, and how it works inside the digital system. I'm not going to require you to know that, but it's interesting if you want to understand how your hardware is doing what you're asking it to do, to understand what 2's complement arithmetic is. So one of the things we as programmers will have to be concerned with is getting input and printing output to our users and from our users. So when I ask for please enter a number from 1 to 10 from the user, they're going to type in a decimal character. So my code is going to have to take a character digit. What if they type in Q? Well, I'm going to have to try to take Q and decide if I can convert that into what I wanted, which was a number from 1 to 10. I'm quickly going to realize, no, there's no way I can figure out Q, meaning a number from 1 to 10. So sorry, user, you did something wrong. I'm going to display an error. But it's really funny writing programs as people when we're expecting to do decimal arithmetic. We know eventually we're going to display our results to a human, and so that human's probably going to want to see these numbers back in decimal again. However, we get the digit from the user. Let's say they enter the character 8. Okay, it's not a number. It's, look it up on this list of ASCII symbols, and it's the one that looks like the sideways up and down infinity symbol. Okay, that character is what they entered on the keyboard. I have to figure out how to get that into an integer variable that I can do math with, I can write expressions against. So I have to convert that in my Java program from character to integer somehow. How do I do that? Well, you could go to Wikipedia and look up 2's complement and figure out how to interrogate every single bit of the character form of the symbol 8 and figure out how to convert that into something representing the number 8. But luckily, we have functions that'll do that for us, so we don't have to do that. So your job here as a Java developer is to learn those functions, learn how to take character data that has digits in it and convert that into an integer data type, okay? And there are classes that have methods that we can call and pass our character data to, and it will return us the data type that we desire from that, if possible, or it'll throw an exception and say, hey, that's a Q, I can't convert that to an integer for you. Okay, and then likewise, we've got a variable sitting here with something that we interpret as numeric in it, and we need to display that to the screen as a decimal digit. Again, going from numeric, something we consider numeric, to something that's in this ASCII table of digits looking characters. And again, we have functions that will do that for us. And so that's what we're going to be doing with this assignment is you're going to be flexing, getting that input from the user, processing the digits yourself programmatically, and then producing the desired output, and you're going to have to manipulate. And I guess I kind of grin, you know, we think we're getting these decimal characters, and we think it's weird enough that we're taking a character and putting it into an integer variable when we're not putting a decimal number in there at all. We're putting a hexadecimal value into a series of, 32 zeros and ones. So the computer's looking at us the same way. It's like, yeah, this joker thinks he's dealing with an integer. No, it's a hexadecimal set of 4 bytes that have a certain combination of bits turned on and off in it. So there's a lot of conversion and reinterpretation and context going on behind the scenes. So here's an example that I threw out there for you as reference to look at. So main function. We haven't really talked a whole lot about this args parameter that gets passed to your main function, but mention it right now. I think I talked about this in one of the earlier classes, but it's just an array of strings that represents the parameters that were passed in on the command line when you executed your Java, my program, and then a list of space delimited parameters that follows. So you can access those parameters that were passed in via the args variable. So if I say, is the length of the args array 0? That says, did you pass in any parameters? If you didn't pass in any parameters, then I'm going to give you a friendly message that says, this is how you should have called this program. Java, signs, the name of the program, and a binary string of digits. So I'm expecting you to type in all character 0 or character 1, but they're characters. Okay, so they get the error message, they try again. Okay, now they've entered a couple of 1s and 0s. So now I say, okay, this string of characters, let's get that from the first parameter that they entered. If it's length greater than 16, then, well, I'm going to make it easy on myself and say you can only enter 16 zeros and 1s. So I'm going to give you another message. So you run it again, and now you've got a string of zeros and 1s that's at least 1 digit and no more than 16 digits. Great. So I have a variable called parsed value. It's an integer data type. I'm using the class integer. I'm using a method in that class called parseInt. I'm passing it a string of characters, and I'm saying 2, which is the base that I want you to interpret those characters as. So it does it for you, right? You don't have to write the code to do that. And so now I can just say, well, take this variable of type int that contains some value, and again I use the integer class, and it's got another method called toABinaryString, and it will take that value. I think of it naturally as decimal. The computer says, no, you're crazy, it's actually hexadecimal, and it converts it to a series of characters consisting of zeros and ones in a representation of the binary value of that. So it automatically does that code for you. It's very nice. So this first line here is to take user input and convert it, interpreting it as binary into an integer. And the second one is taking something that's stored in an integer variable and converting it to a series of characters consisting of zeros and ones. Pretty easy. Likewise, well, printing it as decimal is easy because it does that natively for us poor human programmers. If I wanted to convert it to octal, there's a method that does that. If I wanted to convert it to a hex representation, there's a method that does that. Pretty straightforward. Okay? Everybody see kind of how to access those methods? So when we were examining earlier our code, and I was shifting back and forth between int and integer, that was a clue as to what the difference is. When I use the int keyword, I'm referring to the native integer data type that Java understands. When I use the capital I integer all spelled out, I'm referring to the class called integer that wraps the native integer data type. When I hold my mouse over it, you can see the pop-up says it's a public final class integer. We've even got some inheritance going on here. It extends another class called number. It implements a number of interfaces. And then you have a description there that you can read on your own. But, so this is the class integer. This is just the native data type integer. So int doesn't have any methods. Doesn't have any properties. It's just the basic 4-byte data type. Integer has methods that we can call, as the example showed. Right. And as you'd expect, for that, they generally involve parsing to and from, because that's what we need to do commonly. Okay, another topic. There's this thing in Java called, in object-oriented programming called functional decomposition. So one of the things that you'll end up doing in your code sometimes is you'll write some code, and then you'll think, well, I've already done it here, but let me show you a couple of examples. And I'm gonna change this give it a better method name. It's probably going to give me a red squiggly. No, it's just going to say, do you want to rename your usages? And I'm going to say yes. So it just did it for me. So when I come back over to my main program, it already renamed it for me. Very helpful. That's the editor. It's not a Java thing. That's just an IntelliJ thing. Just save me the keystrokes. Okay, so I've got this method. I mentioned earlier overloading. So let's say I have another version of this, and I only wanted to take one parameter. How would I implement that? Well, it seems reasonable that by default, I want to use the number of years 10 to flatter somebody. So that's going to be my default. So if you call this method without specifying a second parameter, it's going to assume 10. What I have done is I've overloaded the calculate flattering age method. I have more than one usage of the method name with different parameter lists, right? These are unique. Okay? So there's things that I can do here. Let's say for the moment that I don't have that method yet. I just did this one, but now I'm thinking, well, maybe they want to use a different number of years in some cases. I can right-click on this number 10, and where is it in here? Refactor, introduce parameter. And this is, again, the editor, but when I talk about functional decomposition, that's a term for one form of refactoring my code, that there are patterns for refactoring. And when you get further down the road and you get into the study of patterns, software development patterns, these patterns apply across languages, and they're good things to learn, because you write code naively, and let's say you write a couple hundred lines of code, you can go back and examine these refactoring patterns to see which ones apply to your code. Yeah, I think I'm going to leave it there for the moment. That's a big bucket of conversations that we can go any number of directions. But if I say introduce parameter, I click on that, it automatically goes back to adding this, but it says, I don't know what you want this parameter to represent. The number 10 doesn't mean anything to me. So I'm going to type difference and hit enter. And so it created the variable, and it updated all the references to it. What's your related problem here? Oh, yeah, it went back, and that's just a vestigial problem. No problem. So that was going from only having one parameter to saying, well, I'd really like to parameterize this value and bump it up there. So that's refactoring. Go back to this. Okay, so now I've got my overloaded methods again. Got two versions of the method with same name but different parameter lists. This has got two parameters, int and int. This has got one parameter, just an int. And that makes a difference. I could have an overloaded method that had the same number of parameters, but if one of them takes an int and an int and the other one takes an int and a float, well, now they're distinct, now they're unique, so it's okay. If I have, let's say I wanted to use this in two different ways, now I can't. Well, difference is different than product. I want to implement it different ways. Sorry, you can't. Because now it's ambiguous. Now when I come back over to where I called that, I've passed 55 and 10 like before, but now the compiler says, whoa, 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 wait. Which one of those overloaded methods did you intend for me to call? I can't tell. So you have options. When you have ambiguity in your overloaded methods, you have options. The name of the parameter apparently has no bearing on it, right? Just the data type. So I could change the data type. Okay, great. Now they're unique. Now they're distinct. Now they're not ambiguous. I could have different number of parameters. I could even now use the same parameter names. That's okay, as long as the data types, that's all the compiler cares about, is having a unique list of parameter types. I think there's questions on the quizzes and stuff about this too, in case you were curious why I'm spending time on it. Yeah, so that's overloading and resolving ambiguity. You could add another parameter. What? Okay. You know, I could say if I'm if I call it and I pass an extra parameter of true, then I meant you to use the other one. Now we don't use for true for anything, so it's probably going to whine at us about that. But you get the point. It has to have different parameter lists for it to be unique. Another technique that I'll show you, it's a common problem. Yeah, get rid of my true here. Go back to this. Okay, so there's no usages of this method. It's an anti-pattern to re-implement using the same lines of code. Now here it's only one line of code, but it could have been 20 lines of code. So instead of copying and pasting the 20 lines of code and repeating it with the two methods, there's a better pattern for doing that, which is like that. So just in the one that takes fewer parameters, call the other one. And that way, if I ever want to change this, instead of minus, if I want to say times, or plus, or divided by, if I completely change the formula for how to compute this, now all of the different versions, all of the overloaded versions of it will automatically, I've only put this code in one place. Don't duplicate code, that's another pattern. Make sense? When we talk about functional decomposition, that's essentially what we're talking about is we want to take useful blocks of code and create methods from them that we can call from multiple places instead of duplicating the code. You don't want to you want to try to avoid having the same lines of code implemented multiple times. I mean, it's a practical issue that's pretty obvious, but you don't want to, if you find a bug in one of your versions, you don't want to have to go track it down wherever you copy that code to all across. And you think, well, that's obvious. No, I've seen large code bases where I found a bug and then the programmers before me had copied and pasted all over the place, and I had to go do some sophisticated searches through the code base to try to find all the places it also needed to be fixed. But functional decomposition is starting to get into this bigger bucket of things called refactoring and software patterns and anti-patterns. That's a good thing to start cracking open and becoming familiar with. Okay, we talked about static versus non-static briefly, so I don't know that I need to reiterate this too much. I'll just say again, in case I didn't make the point before, that you don't need an instance of the object to call a static method, which means you haven't created the instance and allocated memory on the heap. You don't have to have a reference variable allocating the 4 bytes of memory on the stack to point to that instance of the object. You can just use the name of the class dot and the name of the method to call a static method. If you're just doing simple sequence selection, repetition type programs, which is very common, we're trying to illustrate a point, perhaps our number conversion problem, you might use some static methods if you want. But there's cases when you're writing simple programs, simple console applications where, it's useful it may be useful to use static methods, but you don't have to. What am I doing here? Yeah. Okay. So you see the example. The first line of code here says static object dot, and it's calling a static method of that object. I didn't have to create a reference variable. I didn't have to use the new operator. I just called static object dot and the name of the static method. The next example is similar to the example we were going over earlier, which is I have a non-static, a regular class, so I have to create a reference object, I have to use the new operator, and then I use that reference variable to get to the non-static method. We talked about scope already. There's function scope. Local variables defined in a function are local to that method. When you exit the method, they go out of scope and they get reclaimed on the stack. Variables, reference variables to objects that have no more references get reclaimed by the garbage collector, go back to the heap. You also have, okay, this is making a different point. So you also have other levels of scope. Like if you have a method and inside it you have an if statement. I know we haven't gotten to all the, how you do the selection and repetition in Java yet, but anytime you have curly braces, that defines a context of scope. So anytime something's defined inside curly braces, it's not in scope when you exit and go outside of those curly braces. So remember that. Ambiguity we talked about. Can't have two method names with the same name and the same types in the parameter list. You can rename the value. Oh, also, I didn't say this, but the lack of saying it, it doesn't depend on the return type of the method either. So changing the return type from int to float to void does not make it unambiguous. Because again, the compiler has scenarios where it's like, I don't know which one you want me to call. So that doesn't fix it. You can change the name of the method, or you can change the types of the parameter list to be unique, and that's the way that you get away from it. Yeah, add a parameter. Disambiguation, another example. I think I've already beat this to death. But the point that this slide's making is simply when you're writing code, you need to be intentional about it. You need to be aware of which version of that method that you intended to call. Again, the editor will help you out by putting up the name of the parameter to make sure that you're aware that you are using the correct parameter that you thought in the correct order that you thought. But you need to be aware whether your editor does that for you or not. You need to find out. So in this case, we've got three methods. One takes an int, one takes a float, one takes a double. But if you type 37.2 as your parameter, is it going to call the float or the double? You know, the first one, 17, is an integer, so it knows which one it's going to call. These other two, notice I've defined it 98.6 F, not Fahrenheit, float, right? 98.6 F for float. So now it knows to call the float version. The next example, I use the D, so it's defining it as a double explicitly. So it calls the double version. Okay, we're going on 2 hours with this lecture, so I think I'm going to stop here. How many more of these do I have? Yeah, I'm going to stop here, and we'll get into the Java doc stuff next time. That will be a good place to pick up next time. Okay, any questions so far about all that stuff? There's lots of stuff to absorb, I know. Yeah.
Is the Oracle, the class and method and object, like the online docs, is that all made with Java doc?
Yeah.
The light blue one with like all, really?
Yeah. Yeah, but if you want to start looking ahead for next time, you know, there's the link down there. You can start Googling Java doc or playing with it in your code. You know, it's not too hard, but start playing with it and we'll go over it next time. And the next project is out there, so you can get started on it as you like. Sound good?